Welcome to the Crazy Hat Chemist for another video in bonding. Bam! Today we're doing the basics of polarity number 3. So we're doing all of these 5 molecules here. Which molecules are polar, which ones are non-polar. In order to figure that out, we need to draw the Lewis dot structure. We need to determine the dipole moment for each bond. Then we're going to determine the symmetry of the molecule. And from that information, we're going to determine the molecular polarity of the molecule itself. Today we're doing CH2Cl2. Okay, carbon has an electronegativity of 2.5, hydrogen 2.1, and chlorine, the most electronegative of these grouping of elements, at 3.0. We're going to determine the dipole moment of each bond after drawing the Lewis dot structure. There is our Lewis dot structure without the lone pairs on the chlorines. I'm going to forget about that right now because that's not important for this information. So, I got a dipole moment here. That is, the chlorine is more electronegative than the carbon. That's why the tip of the arrow goes towards the chlorine, because it's more electronegative. And remember, if you get the tip of the arrow, that's negative. Okay? And then the chlorine is more electronegative than the carbon. That's why the tip of the arrow is facing towards the chlorine. And carbon is more electronegative than hydrogen. Therefore, the tip of the arrow is facing towards the carbon, and the same thing with this one. So, okay. This is a tetrahedral structure relatively. This is the tetrahedral structure. So I can draw a molecular dipole to represent this entire molecule. And I want to show you this here real quickly. So these two things right here in green represent the chlorines. These things in the white represent the hydrogens. The black is the carbon, just like before. Okay, and this is kind of how this looks here. So it almost looks like you can split the molecule in half, but you really can't. It's this side is different than this side. If one side is different than the other side, then you have a molecular dipole and a polarity for the molecule. This is most certainly polar. Okay, it doesn't matter how you turn it, how you face it. This end is different than this bottom end over here. The top end is different than the bottom end. Therefore, it's asymmetrical and therefore polar. So that's what this information is telling us. CH2Cl2 is tetrahedral. The dipole moment for each bond is drawn in the red. It has asymmetry here, and therefore there's a molecular dipole, and it yields to a polar molecule. So this will align itself in an electric field. Okay, make sure you take a look at that molecule. Make sure that you understand that that is asymmetric. You can't just slice it in half with a knife like most people think, but it is not. That's not how it works. This side is different than that side. It is polar, most definitely. I'm the Crazy Hat Chemist. I got a great hat here for you. Happy 4th of July or whatever you celebrate. Give me a thumbs up if you like that video. Subscribe to my YouTube channel and spread the word that the cool chemistry videos are right here on the Crazy Hat Chemist. Spread the word, baby. Bye now.